Okay, so here we are, part two. We did converting between polar and rectangular coordinates, and now we're doing converting between polar and rectangular equations. So it's a very similar process. It's just now we're thinking about the whole equation instead of just the coordinates. So I've already tried to save a little time because I don't write very quickly and neatly. If I have to do, I can do one or the other, but not both. So we're going to convert equations. We're going to start with rectangular to polar equations, and then we're going to do polar to rectangular equations. So rectangular is our x, y coordinates, to polar is our r, comma, theta coordinates, right? So let's just pick something really simple to start with. And when you're converting between these equation types, what you're going to find is that you're going to have to start to think a little creatively. You're going to have to start to scan your mathematical toolbox for which particular tool works in which particular instance, okay? And that's just what happens. The higher up you go in math, the more you have to just sort of keep your toolbox there and know what you have available to you to accomplish what you need to accomplish. So in this case, we have x plus y, and we're just going to say x plus y equals 3 for the moment. And what we need to do is get that equation into a form that is, here is x in terms of y, right? And you could do y in terms of x or x in terms of y, whatever. We have x and y. But we want to get r, this needs to be changed into a r and a theta, right? And probably we're going to want to rearrange it so we can stick in 1. And like this one right here, if we wanted to make that useful, we would say y equals 3 minus x, or negative x plus 3 or whatever, and then we could stick in an x and get a y, right? That's a more useful form. So probably we'll end up wanting to get r by itself and that. But let's get started. So we are trying to find, this is the basic thing. You got an x and a y, and you want to find x and y in terms of r and theta. All right, that's the goal of what we're doing. So let's sketch it out. Just pick the. I know it's an equation, but we're just kind of going to sketch to get a flavor of what's going on, because that's really going to help us find. Because what we're looking for is the relationship between x and y, and r and theta, and then we're going to put that in there. All right. So basically, we know what are we going to know here? We know the x and the y, and we're trying to find the r and the theta. So we have r, we have theta, we have x, and we have y. So what we're going to try to do is find out a way to change the x to some version of theta and r. And we kind of already know how to do that, right? Because that's just trig. So let's write our basic trig function. So ka toa right up here. And then, so if we're going to relate x to theta and r, how do we relate x to the angle and the hypotenuse? Well, x is the adjacent leg, right? So we're going to use cosine. So we're going to note that cosine of theta equals the adjacent over the hypotenuse, right? There we go. But we are trying to get something that x equals, because once we get something that x equals, then we can stick that thing in this equation for x, right? So in this case, all we have to do is take that r and put it over here. R cosine theta equals x. Now we have something we can stick in that equation for x, right? Boom. Now you can see where this is going, right? How are we going to relate y and theta and r? Well, that's the sine function, right? Because the sine of this angle equals the opposite leg over the hypotenuse. So the sine of theta equals y over r. Good? Good. Okay, and then we're going to do the same thing. Put the r over there. R sine theta equals y. So now we have something, we have a relationship between x that can be related to theta and r, and we have a way to relate y to theta and r. So now we can just substitute those two things in. Instead of x, so here's our original equation. equals 3. And then we're going to, our x equals r cosine theta, right? So we'll put r cosine theta there. And then we'll put plus, and our y equals r sine theta, right? Let's do this just to make that clear. R sine theta equals 3. And we could be done there, depending on what the instructions require, or whatever you're trying to accomplish requires. But let's just finish this off, and we're going to get r by itself so that you could get an angle theta and find out what the r is in this equation. So we're gonna factor out that r, right? So then we're gonna have r, and then we're gonna have cosine theta plus sine theta equals 3. Okay, and we're going to divide both sides by r. So then we're going to end up with cosine theta plus sine theta equals 3 over r. And then we're going to invert both sides. If as long as you do the same thing to both sides and you do it to the whole, both sides. I mean, we could do it longhand. I could multiply this times some stuff and you know, jigger it all around, but the shortcut, and I'm actually not a fan of shortcuts generally, like cross multiplying and stuff, but in this case it's just so easy to just go whoop. So that's what we're going to do. So we're going to say 1 over cosine of theta plus sine of theta equals r over 3. Then we're going to multiply both sides by 3, and we're going to end up with 3 over cosine theta plus sine theta equals r. And this equation is the equivalent of, where is it? This equation right there. Those two, if you go open up Desmos or something and put those two equations in, and you will find out they will yield exactly the same thing. In this case, it's a line. I do want to point out one thing, because you might run across it. And this is totally extra. This doesn't have to do with the problem above. But if you remember from the unit circle, there's the x and the y and the r on the unit circle, and r equals 1, right? And so if you have, and the x is the cosine on the unit circle, x is the cosine value, and y is the sine value. So just if you run across this, cosine theta plus sine theta, sine squared theta, what is that going to equal? That's going to equal 1. And so if you run across this, you can take that whole thing out and stick a 1 in its place, which you might run across. All right, well, now let's try it the other direction, shall we? So we went rectangular to polar, and now we're going to go polar to rectangular. So let's make a polar equation, and we'll do this one. R equals 4 sine theta. All right, how are we on time? All right, so we should be able to finish this up in a 12-ish minute or less. So now our goal, what's the goal of this if we're going polar to rectangular? So always keep in mind what you're trying to accomplish. Our goal is to relate r and theta to x and y. So we need to find out what x is in terms of r and theta, and what y is in terms of r and theta, right? So let's start by just sort of thinking about this again. So we have a good thought here, and we're going to have an r and a theta and a y and an x. All right. So this particular equation is where we're going to start to have to do that sort of creative math thinking, and you're going to have to know what relationships already exist, what's out there, what tools are in your toolbox, what pre-made things there are that you can modify this equation with. It's going to be like completing the square, sort of, in that you're going to add something to make it into a convenient form. So that's what's going to go on here. So let's put this down here again. R equals 4 sine theta. Now, sine theta, we got a sine theta and an r, but we can't just divide by r because then we'll have sine theta over r. But if we could get r sine theta, what is r sine theta? We already know what r sine theta is in terms of y because we just did it over here. So r sine theta equals y. So we're going to do a little bit of mathematical trickery. And we're going to multiply both sides by r. So we're going to have 4r sine, we'll put these in parentheses just like that so it's easy to see, 4r sine theta, and then this is going to be r times r, which of course is r squared. All right, so we'll put an r squared in here, and we're going to have a 4, but we already know that r sine theta is y, right? So we're going to take this bit here because we already know we can stick a y in there, and then we're halfway done. Geez, already, look at that. 4y. Can that be true? It has to be true. It's math, unless you do it wrong and then you go to math jail. But this is not wrong. So what are we going to do with that now? Well, is there a predefined relationship between x and y and r squared? Is there a predefined relationship that you already know between r squared and x and y? I have to pause for a moment. All right, I'm back. So do you know a predefined relationship between x and y and r squared? You do. It's the Pythagorean theorem, right? It's x squared plus y squared equals r squared. And you, my lucky friend, happen to have an r squared right there. So now we have x squared plus y squared equals 4y. And we are 2/3 the way home already now. Easy. So now all we want to do is rearrange this. If it's an x squared and a y squared, what does that look an awful lot like? Some sort of ellipse, right? Could be a circle, but certainly at least it's an ellipse with an x squared and a y squared. So we're going to start to do our little bit of math here and see if we can turn that into a form, because you might get a question that says, what is the center of the circle defined by r equals 4 sine theta? And you would have to be able to do that, which would mean you'd have to be able to get it into a different form. And the easiest thing to do, if you can do it, is to get it into a standard form of a circle, which we can do here pretty quickly. So we got x squared, that's nothing. We got a y squared and a y term, so that looks like a good candidate for completing the square. So I'm going to subtract 4y from both sides. 4y minus 4y equals 0, and I'm leaving a space because what I want to do is complete the square on this. Okay, so we've got y minus 4y. How do we complete the square? Well, we take, if these are the ones we have anyways, we take this coefficient and divide it in half, so -2, and then we square it. And that's going to give us +4, right? And the reason we do that is because we want this whole thing to condense into y minus 2 squared. And just to review that again, we had these two, and we looked at this one, and he said, well, when we FOIL this, we're going to need to have that times that twice. So we can take this number here, this coefficient, and divide it by 2, which is going to give us -2. And then we got to put something in here to make it the full square deal. And so -2 squared is +4. And so now this whole thing condenses down to y minus 2. And we have x squared plus right there. That doesn't change. The only other thing is that we added 4 on this side, right? So we have to add 4 on this side. So we're almost there. That's not quite the form of a circle, but it's pretty close, isn't it? What do we need over here to make a circle? It has to be a 1, right? So now we're just going to divide both sides by 4. And so on this side of the equal sign, 4 over 4 equals 1. On this side of the equal sign, we're going to break that common denominator up on either side of that plus sign. And now things are going to look super familiar to you. Does that or does that not look like a circle? It is. What's the center of that circle? The center, whether it's ellipse or a circle, is what? H comma K, right? And so H is 0 because there's nothing there. And K is 2 because the negative is part of the standard equation. So that's a positive 2 right there. So that's the center. And then you got the square root of that and all the other stuff about the circle. So that's it. And feel free, if you're in my class or if you want to email me, I don't care. I don't think I'm going to get a ton of them. And you need help with this more, let me know. All right. Take care. Bye-bye.